Hello, Mr. Prize Geometry class. I'm looking at this Unit 12 Probability Homework 1. Today is March 15th. This is due on the 16th. I believe it's called Sets slash Venn Diagrams in your Google Classroom. Taking a look at the odd ones mostly, but I will jump in some even ones too for a little bit of help and guide you along the way. And hopefully you could do the ones that I don't go over on your own and try them and learn from your mistakes if you make any. So for number one, we're to define each set and then classify it as finite or infinite set. So the days of the week, well, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, it's a finite list. When you do number two, odd numbers greater than 9, you can just start counting them. Do the ellipse. That's going to be infinite. It's just going to keep going forever and ever. Number 3, hopefully you're pausing this as I go through this too, so you're getting all this. The months with exactly 30 days. That would be April, June, September, November. That is a finite list, meaning that it ends. Number 4, positive factors of 24. Well, you just list those factors of 24, and if you're not sure about them, you can just Google that, and it should be a finite list. Number 5, states that begin with letter B. There are none. I put finite, but really what you want to put is empty set after I thought about it. Empty set. That's just going to be an empty set there. Multiples of 7. Well, I have 7, 14, 21, and that would go on forever and ever. It's infinite. That would be an infinite set. Okay, so if the universal that we're looking at set are these numbers, and A is this, what would this one be? That would be everything but these numbers, okay? Because then, A1 goes with A to make the universal. B, I also, or 8, I'm sorry. Thought this looked like a B there for a second through my phone. So the universal set of numbers the numbers on a six-sided die, and B is the set of numbers on the six-sided die greater than 3, and what would be 1B? Well, those would be the ones that were 3 or less, so that would be 1, 2, 3, and then so your B would be 4, 5, 6, and then you put them together, the union of those would be 1, 2, 3, 4, 5, 6. Try 9 on your own. Number 10, I do go through every other one of these. So the intersection of A and B, the intersection of A and B would be those that are shared in both A and B, and that would just be 4, 14, and 20. When you do B, the union of B and C, so you would write 1, and we might as well do this one together. 1, 2, 3, 4, 7, 9, 10, 14, 17, and 20. See how that works? The union of the two. Put the two together. So that's both of them together, not only what they share. The union of A and C, same thing. You're putting A together with C. So put those two groups together. D would be the intersection of A and C, just what A and C share. Just list what A and C share in those fancy brackets. I just kind of do a squiggly line. The intersection of B and C is an empty set. They do not have anything in common, so that's an empty set. The union of A and B, just put A and B together, and just list all those down together. Okay. For number 11, we are going to take a look at, and actually I didn't know that they were going to ask this down here. This actually goes right here. The B would go right here. And then if you could do the intersection, what they share, that's just what you have right here, the 1 and 9. And then the union of A and B, all of these numbers together, okay? And I utilized this. This is going to be the universal set are just all the natural numbers, no more than 20. So 1 through 20. No more than 20. Oh, okay, so I could have listed 20 there, so I did keep 20 out. So I would put 20 over here. add 20. Sorry about that. Slip of that 20, and that's a tiny little 20 down there. Okay. The set A is going to be the perfect squares. The perfect squares are 1, 4, 9, and 16. But these are also odd numbers. 1 and 9 are odd numbers, so it also shares the characteristics of B. So that's why it's in this section of the diagram, the Venn diagram here. And set B are all the odd numbers. So that would be 1 through 19. Okay. So I'm sorry, just all the odd numbers. I don't want 20. That's why I left out 20. Sorry about that. So that's why I left out 20, because B is just all the odd numbers from the universal set. Okay. That's why there was no 20. Sorry about that. I knew what I was doing in the first place. So once again, so this is the diagram filling out the Venn diagram. These are just the odd numbers. These are the odd numbers that also share A, that they're also perfect squares. These are just the perfect squares, and they happen to be even numbers, so they can't touch the B circle. So universal, I think we could have 20 out here. If there's anything, so outside of both A and B, 20 is the only number that doesn't really fit in either A or B, so I can put a 20 out there. All right, so once again, 12, this is your answer for 12, just that set for A. The set for B is this right here. I was like, man, I have to see these in order to do this out, fill this out, so I wish they would have had this first, and then you could have made the diagram. And then just do the intersection, just what A and B share, and you have it right here. Just it's going to be 1 and 9. So you do have those answers. Jumping down to 17, we're given two sets, and we're determined if one set is a subset of the other. If yes, describe the relationship using proper notation. So if one set is a subset of the other. Okay. So yeah, I guess so for 17, months with 31 days and months that start with the letter A, and there was one that would be August. The set of integers and factors of 60. So this would be a subset of the set of integers. Okay. And we have number 20, I could get you started on this. How many students ski or snowboard? So ski or snowboard only. So you're going to put that 13 together with that 10. So you should have 23 there. How many students ice skate and ski? Ice skate and ski. Ice skate, ski, where they overlap, 2. How many students ice skate, ski, and snowboard? Ice skate, ski, and snowboard. Just that middle number right there, that 3. How many students do not ski or ice skate? So they do not ski or ice skate. So they could snowboard, or they could do nothing at all. So probably 10 and 6 there. So 10 plus 6 would be the 16. How many students just snowboard? Just snowboard all by themselves. That would be 10. How many students do not ice skate, ski, or snowboard? That's going to be your 6. How many students ice skate? So just ice skating in general, so add all these up. 7 plus 3 would be 10 plus 6, so 16 for G. How many students do not snowboard? So not snowboarding at all. So we're going to have, they could ski. They could ice skate and ski. They could just ice skate, or they could be nothing at all. So we could have, this would be 20, 22 plus 6, so 28 do not snowboard. And how many students took the survey? So how many students took the survey in all? Just add up all of these numbers that you see in here, and that's how many students took the survey. I'll leave that one to you on your own. Good luck with the rest. Hopefully this was helpful.